Okay, so hello everyone. So my topic for this talk might sound a little surprising, so I'm going to talk about static typing and JavaScript. And well, JavaScript is a dynamically typed language, so how come I'm going to talk about static types? So let's see. So I'll start with a very simple statement, like types are there in every program. Like in every program, like all the values that you manipulate with have certain types. And I do not actually mean types in the computer theory sense, like in the Haskell sense, but simply types, like kinds of things that you are working with, strings, objects, like objects of a certain kind that have certain attributes and so on, or functions which have like specific set of arguments and so on. And when you're writing a program in any language, you have to understand what the types are in order to be able to understand code, to reason about code, and in order to be able to write code. And I'm not sure if it's wise of me to show an assembly language example on a JavaScript conference, but this is just a single instruction, so hopefully it's not too hard. So obviously at the CPU level, there are no types. Like there are like numbers that are put into registers and are stored into memory and so on. But in order to make sense of this instruction, in order to understand why it's +4 and not +8 and what this thing does, you need to know what the value of the EDX register points to. You have to know what the type is of this thing that is stored in the memory there. And this, of course, this also applies when writing JavaScript code. And when you have when the information is not expressed in the source code, when you just have like a parameter declaration, what's this O thing? When it's not expressed in the source code explicitly, you still have to know what this is, and you still have to understand what this thing is about. And of course, there are multiple ways how you can understand what this is about. So if it's a framework function, then you can read the documentation for the framework, and you can see what it says about what the particular function expects, or what it gives you as a parameter. If it's your own code, you can just look around and see how this function is called, try to understand the context, and try to figure out what this thing is. You can try to give parameters. You can try to give meaningful names to the parameters. So from the name, from the name you can probably figure out what the type of the thing is. But all of this is extra cognitive load. So it's an extra thing that you have to think about when you reason about the code. And in some cases, it's just automatic. In some cases, this is not just as easy. Especially when you have a large, complicated code base. Especially when you are reading the code that someone else wrote, and if it's not just like couple of jQuery adapters to make some things move on the page when it's like real big, large-scale JavaScript application. And of course, the type system needs to be able to express what the code is about. And type systems of languages like Java, they are actually quite rigid. So you have classes, and the class has a fixed set of members, and you have to list the members when you are defining the class and so on. And with JavaScript, people want to have more flexibility than that. They want to have like objects which have properties. They can add some properties, and they can inspect what the properties are there. They can make decisions depending on whether some property is there or not. So the type system that you are using, the static type system, needs to be expressive enough to be able to state all of these requirements and state all of these points in the type declaration. But the interesting thing is it is actually possible to to infer the static types that were meant by the JavaScript library developers. So this is the definitely typed project on GitHub, where people actually, after the fact, take JavaScript libraries written by the community and come up with static type declarations for all of the functions in those libraries. And you can see they cover like a huge set. So this is just not a complete list of the libraries that are there. And it is actually possible when you have a good language with a good type system to express all the types that have been used by those libraries. And so like in any piece of JavaScript code, it is also possible with a good enough type system to express your intentions and your requirements. Another common misconception about types is that like types slow you down when you change code because you have to adapt. You have to go in and make sure that the types actually fit, and you have to go and change the type declarations when you are altering the code. But this is actually not quite true. So it is true that you have to like go and worry about the types. But this is still extremely useful to be able to understand So the types are not there for the sake of themselves. They give you a list of all the places that you have to change when you are changing a particular piece of code, in order to make sure that your program fits together, yet that you do not end up with a like square peg in a round hole situation. And if you don't have types, you have to run the tests, and you have to like go through the test failures and understand what exactly needs to be changed because of this test failure. And you have to make sure that you have enough coverage, enough tests covering your program. And like types save you a lot of pain in this regard. And of course, a very good thing about types is that you do not have to have them everywhere. So if in some particular place, like it's a simple event handler that takes like a parameter, you know what the parameter is, you are not ever getting confused by that. So you just leave it as is. But you can specify types in like more hairy, more complicated pieces of code, simply to support your thinking, simply to make it clear what happens in every particular place. Now, how can you actually put types in your JavaScript? So this was like a bit of the why part, and so how can you actually do that? So first of all, there are a bunch of languages that compile to JavaScript and that like have fully supported static type systems. So these are just a few of them. There are actually like others. So Kotlin is made by JetBrains, so this is also something that I have worked on previously, but this is not what this talk is about. So all these languages are nice. They give you a lot of power, but they require you to essentially change the language in your project. And in the JavaScript community, it can be often a very controversial topic, and there are like many reasons why you do not want to do that. And so this is not what I'm going to talk about for the meat of my talk today. What I am going to talk about is JSDoc, which is actually a great tool, and it is much more than just a code generation tool. It is a tool that lets you simply document your code by adding parameter names, like describing functions, specifying what the purpose of the parameters are, and so on. But it does much more than that. It has actually built-in type system that allows you to express like all of those things that I was just talking about, all of the requirements, all of the expectations that you have about functions, all of the like all the parameter types and so on. Okay. And beside the documentation, there are also tools that can make use of this additional information to do error checking and to improve your code experience when you write code. So Google Closure Compiler is an example of a tool that does quite extensive type checking based on JSDoc information. And Webstorm is the tool that I'm currently working on. It's an IDE for JavaScript, and it can extract a lot of value from JSDoc comments, and I'm going to show you how exactly. So the problem with JSDoc is that there are actually there is just no single standard JSDoc format that like everyone knows how to use. There are like multiple versions of that. There is like JSDoc 3, which is like the new kid on the block. There are multiple like older tools that use different dialects of JSDoc, and also documentation that is not quite JSDoc, but similar to that in its form and function. But the things that I'm going to show you now are like mostly there is a common ground between all of the tools, and and you can use it for your project. And just to show that it's not that like there are like real people out there that use JSDoc for their comments. This is just a piece of the Firebug source code. And here you can see an example for how this is used. Like this is the most common thing, the param tag. So the parameter, it has a type string. The name of the parameter we are documenting is expression, and like what it means is the expression, which is, I guess, not very useful. And once you have this kind of information, let's see what you can do with that. So for example, here's a very simple example, a function that has a string parameter, and we are calling it passing it an integer. So in this case, it's not going to crash at runtime, but still, it's something that we want to be able to get a warning about, because we are not using the function in a way that I meant. And this is an example of a message produced by the Google Closure Compiler to notify you about the error. So this is not an error. Actually, this is a warning, but it still tells you that the actual parameter does not match the formal parameter. So it's not a string; it's a number. And now let's see what additional checks can be performed by Webstorm, for example. So yeah, this is a function that takes an object, and this object has to have this number of fields, like name, age, and an optional profession field. And when we are passing some specific objects that we also declare the type of, we can get a warning about the mismatch of the type. So like we are passing a structure that only has a string as a string field, and the structure that the function expects must have the string and the number, so the function is going to crash, and we get a statical type warning about this. Yeah, this is a simpler example. We are simply defining the structure inline, and we are passing it to the function. JSDoc also gives us a way to express certain, certain class-like constructs. So yeah, JavaScript uses prototype inheritance, but people want to use it like a more object-oriented language. And JSDoc has tags to support this. So the class tag specifying that the particular function is a constructor of works as a constructor of a class. You can mark one class as extending another class. You can declare static members and also declare the types of them and so on. And this actually gives you a common ground among all of the different JavaScript libraries, which each of those implements their own concept of inheritance and so on. And this is just how you can express all of those in a simple way. Also, continuing the object-oriented programming topic, you can also express that some member is private. Of course, this is not enforced at runtime, so there is no real encapsulation in JavaScript. But in an IDE or when compiling your code, you can get warnings about trying to access private members of a class. Another concept supported by JSDoc is the concept of interfaces. This allows you to say that an object that you pass to some function needs to have a certain set of methods. Yeah, this interface tag is used to do that. And you can also mark an object that as requiring to implement some interface. And if it does not actually implement the interface, then you get a warning because like the implementation of the interfaces are not there. And once you do that, it's very easy to generate the implementations in Webstorm. So you can just invoke the implement methods quick fix, and the implementations are generated for you. So it's quite easy to use. The next concept is enums. So just the set of when a function takes values that need to be in a particular set, you can annotate this set as an enum. And when you are trying to pass or to assign something else to a function, you get a warning about not like this thing is not assignable, it does not have the right type. You can also, the next thing I'm going to show is the typedef tag. So the typedef actually allows you to give a short name to a particular set of, like a set of object fields. So, like if this is an object, like if this is a set of fields that you commonly use, when it does not have like a class or like a specific class that a constructor function, you can just take this thing and give it a particular name and like use it in your code and according to this name. And so in this case, yeah, you can simply once you do that, you can use it as simply in param tags and in type tags just all over the place. There are many more tags in JSDoc. I'm not going to talk about all of them because this would get quite boring quite quickly. But just the key concepts are the ones that I have shown previously. This is another example which shows how JSDoc can be useful. And in this case, the JSDoc that we are talking about is the documentation for the standard JavaScript functions that we have as part of the Webstorm distribution. So in this case, we are making a mistake that's very easy to make accidentally. So to the setInterval function, instead of passing the function itself, we are passing the return value of the function, which is not going to work because this function does not return anything, just returns undefined. And Webstorm can actually highlight this error. And so yeah, actually, yeah, here you can also see that the type system allows you to express alternatives in type. So this thing must be either a string or a function. This pipe marker means that. Yeah, and this is how we declare the types for the expected types for the setInterval function. It's just part of like these documents are just part of the standard distribution of Webstorm. We are simply maintaining this information to make sure it's accurate and reflects all the stuff that's going on in the browsers. Another thing that another feature of Webstorm that relies on static type information is parameter information. So it's a very easy way to get a tooltip for the function that you are calling to check whether the parameters that it takes match your expectations. The code completion can also make use of static typing information. So in this case, we have declared the parameter as an element. And so the completion variants are generated based on knowing the type of this value. And so it's an element. And so we show the list of members for element. This also works in slightly more complicated situations. So in this case, we have declared that the change function takes a callback, and in the context of the callback, this is going to be an element. And so now we are calling the change function and invoking the code completion for this. And once again, we get the list of members for element. So this is also quite handy. In the next example, we are also seeing another common pattern in JavaScript libraries where we have an object which has, so instead of adding multiple parameters for different separate parameters for different options that a function can take, we just make a single settings object, and we put all of the things that we want to pass to the function as attributes on the settings object, and we're declaring the types of those. So that, like in this case, the settings object has a context parameter and a URL parameter. And we are calling the Ajax function, passing in an object literal, and inside the object literal, we get the completion for the parameters that we have declared. Webstorm also has a bunch of features for helping you write JSDoc comments. And so, for example, in this case, we have a function, and we have started writing a doc comment for it. So we have simply typed /***, and we simply press enter. And once we do that, we get a stub for the doc comment. So we have actually analyzed the code of the function. We have tried to infer its return type, and so we have generated the returns tag for you. And because we don't know anything about the object, we just leave the parameter declaration as is, so you can complete it as you need. The refactorings in Webstorm also work with the JSDoc comments correctly. So in this case, we are taking a function, and we are going to apply the introduce parameter refactoring to it. So we select the piece of code. We press the shortcut to invoke the refactoring. And it offers us the generate JSDoc option. And then when we invoke the refactoring, you see that the function that we have generated has the parameter tag with the correct parameter type. We also have a bunch of quick fixes to correct faulty JSDoc comments. So for example, in this case, we have a variable that has actually a type of string, but is annotated to have as having a type number, and we can invoke a quick fix to correct this for us. So we invoke it, and it changes the JSDoc declaration. Also, a common case is when we have a JSDoc comment that does not include any information about types, and includes just a description of the function. And we can invoke the fix doc comment action, the fix doc comment action, in order to bring to complete the JSDoc declaration with all the stuff that needs to be there. So we invoke the action, and now it gives us the actual results that gives us the parameter and the return type declarations. Actually, so yeah, as I mentioned, so JSDoc has quite a sophisticated type system, and it's also interesting that the type system of JSDoc maps quite well to the type system of TypeScript. So, like for many things supported by JSDoc, there are like good equivalents in the TypeScript type system. And what this lets us do is actually it lets us use a single internal representation for all of the types in your program, and to also use the declarations created by the TypeScript community in order to improve the quality of the code completion in your JavaScript code. So even if you're writing in plain JavaScript, even if you don't use any TypeScript in your application, you can still download the TypeScript stubs, and they are going to improve the code completion experience very significantly. So we have a specific action for that. You can just go download and install a library, select the TypeScript community stubs. There is like a long list of libraries that are there, and you can select the one that you need, and it will be downloaded as part of your project. This is what the declarations in those libraries looks like. So just route interface, like callbacks, methods, and stuff like that. And here's how the code completion works when you have this information. So once again, this is pure JavaScript. There is no TypeScript anywhere in your project, just in those stub files. And still, we get all of the assistance all of the useful information that is contained in those stub libraries. So that concludes my presentation. Actually, so as you have seen, there is a lot of power that could be gained by simply using JSDoc to annotate your JavaScript code with additional information about the types. It's going to help you with refactoring. It's going to help you with code completion. It's going to generally help you make your code easier to maintain. And you can apply this technique exactly when you need it and exactly to the degree that you need it, where it is actually helpful, and simply the places where it's not helpful, just leave them alone. And there are tools that can make a lot of that can extract a lot of value for this information, make your life easier. And yeah, Webstorm is one of those tools. Google Closure Compiler is another. And yeah, please go and use JSDoc for your projects. And I think we have some time for questions.
Yeah,
still.
good. 5 minutes for questions if anybody wants a question. Yep.
Hello. Hello.
Hi.
Yes, I'm a bit slow today, so I'm sorry if this has been covered. But I wondered, what if I wanted to do like a postal code as a type? I basically want the string, everything that the string is. Like, so I don't really want to create a new class for it. So is there any of this technology that would allow me to just sort of say that this function returns a postal code? It just happens to be a string, but I demand that it's being called a postal code, and functions taking postal code will require it to be this and not just a random string.
I'm actually not quite sure. So I think the typedef tag can allow you to do that. So you can like typedef string as postal code. And I'm not sure if the static checks are going to be able to catch like you calling this incorrectly, but at least you will have this information written in the code for you, so that you can see that this takes a postal code.
Okay, thank you.
Hello.
Hi.
Hey.
Hi.
So, given that JSDoc is completely unrelated to the code that you comment, so you can add synthesizer functions, you can synthesize properties, etc. How do you think editors should react when you try to, mock them or fool them? Like you declare a property that doesn't exist or contradicts what you write in the function. Does it, for instance, does Webfront autocorrect this or suggest?
So if actually for something like object attributes, we do not. So if you are declaring an attribute that is not explicitly defined anywhere in your code, we do not try to highlight this as an error. So we simply we assume that you created somehow in some way that we do not understand, and so like if you declare that the attribute is there, then it's there. For something like a function parameter, if you, for example, if you have a parameter that if you document a parameter that the function does not actually take, then we do highlight this as a warning, because most likely you made a mistake when you renamed the parameter and forgot to update the JSDoc or something like that. So in this case, we do highlight this.
Anyone else? Well, Dmitry's here, so if you have any more questions, you can just come up and ask him. We're breaking now for an hour. It's lunchtime.
Thank you for your attention. Thanks again.